Hello and welcome back to our discussion on quadratic equations. So we're going to be looking at the method of factorization of quadratic equations of the form ax squared plus bx plus c equals 0. So let's look at an example. X squared plus 5x plus 6 equals 0. Let's factorize it. So the method is, the way I was taught, is find two numbers u and v such that u plus v equals b and u times v is equal to ac. So here b is 5 and ac is 6 because a is 1. So two numbers whose sum is equal to b and whose product is equal to ac. So this is the underlying principle in the method, right? So let's do this example. So find two numbers that add to 5 and multiply to 6. So the answer is 2 and 3. Now with those numbers, we can now split the b term. So bx will become, which is 5x, sorry, that will become 2x plus 3x. So it will become ux plus vx in general, if you think of it in a general sense. But we won't write u and v here. We'll just write 2 and 3. So the original equation, x squared plus 5x plus 6 equals 0, now becomes x squared plus 2x plus 3x plus 6, and that equals 0. I will do the general case in a minute. I wanted to show you a specific example first. We'll prove the general case shortly. Okay, so let's factorize that. So the common factor on the left pair is x. So x times x plus 2. Copy your x plus 2 over, and then a 3 will come out. So you'll have 3 times x plus 2, which is 3x plus 6. And then group them all together, you get x plus 3 times x plus 2. And that equals 0. So the roots are x equal minus 3 and minus 2. So we factorized this into this. So it boils down to x plus 3 times x plus 2. And then we can quickly write our roots down. And then a quick check will show that the sum of the roots is minus 5, which is minus b over a. And the product of the roots is 6, which is also c over a. And that's what we expected. If that was not the case, then we've done something wrong. Then none of it makes sense. It's nonsense. Thankfully, it's worked out nicely. So that's a specific example of factorization in action and showing that it works. And the whole basis of it is this idea here, where you have two numbers whose sum to b and whose product is ac, and then you use those numbers to split your x term. So when you split your x term, they become the coefficients of the two x terms. Okay, so you'll have x squared plus ux plus vx plus c equals 0. A is 1 here, that's why I didn't say a. But in general, okay, if you look at the general form, ax squared plus bx plus c equals 0. So that will become ax squared plus ux plus vx plus c equals 0. But we're going to look at that in a little second. I'm going to do a general proof of all of this.